Okay, so if I asked you to name a single year that completely changed the world, what immediately comes to mind? Maybe you think of the year a major war ended, or maybe the year the internet finally went public. But what if I told you that the ultimate inflection point in 20th century science, the year that literally laid the absolute groundwork for the reality we live in today, happened quietly over the course of just 12 months in the early 1950s? Welcome to this explainer. Today we're going to dive deep into 1953, the year the future began. Just look at the relentless, almost overwhelming pace of innovation that happened in this one single 12-month span. It's honestly staggering. In February, the structure of DNA is uncovered. Then, in March, the first polio vaccine is announced. By May, we get the first successful open-heart surgery using a heart-lung machine. And then in November, one of the greatest scientific hoaxes in history gets definitively debunked. We're going to unpack exactly how all of this happened in one incredible year.
Here's our roadmap for this explainer. First, decoding the secret of life. Second, miracles in modern medicine. Third, building blocks of tomorrow. Fourth, uncovering truths and hoaxes. And finally, the legacy of 1953.
Section 1. Decoding the secret of life. Uncovering the blueprints of existence.
All right, picture this. It's February 28, 1953. Francis Crick and James Watson excitedly walk into a local Cambridge pub called the Eagle for lunch, and they just announced to the patrons, "We have discovered the secret of life." The sheer audacity of it is kind of comical, right? You go in for a pint, and someone casually announces they've solved the foundational mystery of biology. But here's the thing. It wasn't a boast. It actually happened. They had just figured out the double helix structure of DNA, which is, quite literally, the blueprint of life itself.
2 months later, on April 25th, this earth-shattering realization was formally shared with the world. Crick and Watson published their article on the molecular structure of nucleic acids in the British journal Nature. Now, this work is renowned for revealing the structural beauty and the functional logic of the DNA double helix. But we have to remember, this monumental milestone didn't just happen in a vacuum. The publication was accompanied by absolutely critical X-ray crystallography results from Maurice Wilkins, as well as a third related article on molecular configuration by Rosalind Franklin and Raymond Gosling. Together, these joint publications beautifully illustrated the mechanics of DNA and laid the absolute groundwork for all modern genetics.
And get this, just weeks after the DNA structure was published, another massive biological breakthrough dropped. On May 15th, Stanley Miller published the results of the Miller-Urey experiment in the journal Science. This experiment completely stunned chemists. It proved that organic molecules, the actual stuff of living organisms, could form easily from simple inorganic chemicals under conditions that were thought to resemble a primitive Earth. Just think about the magnitude of that for a second. Scientists were literally watching the origins of life come into scientific focus right there in a lab.
Section 2. Miracles in Modern Medicine, from the microscopic to the human scale.
So having uncovered the blueprints of life, science in 1953 also took massive, unprecedented strides in preserving it. On March 26th, Jonas Salk announced his first polio vaccine, striking a massive blow against the disease that had paralyzed entire generations with fear. Think of the immense global relief that singular announcement brought. Then, just a bit later, on May 6th, surgeon John Gibbon performed the first successful open-heart surgery using a cardiopulmonary bypass pump, a heart-lung machine. He actually repaired an atrial septal defect in an 18-year-old girl named Cecilia Bovalek at Thomas Jefferson University Hospital. These two achievements, they didn't just make headlines. They rippled outward to literally save millions upon millions of human lives in the decades that followed.
So we were fixing the heart and conquering viruses. But 1953 also looked inward, right into our own heads, which brings us to an entirely different kind of mystery. What else happens when we close our eyes?
It turns out, 1953 fundamentally altered our understanding of both the sleeping brain and the architecture of human memory. In September, researchers Eugene Azarinsky and Nathaniel Kleitman published the very first discovery of REM sleep, rapid eye movement. This finally gave us a scientific window into the active dreaming brain. That exact same week, a neurosurgeon named William Beecher Scoville operated on a man known as patient HM, Henry Mollison, to control his severe epilepsy. He removed most of HM's medial temporal lobes, including his hippocampi. Now, while it successfully helped the epilepsy, it permanently stopped HM from forming any new memories. It's this profound, tragic paradox. Henry Mollison lost his own ability to remember his life, but his personal tragedy inadvertently gave humanity the monumental gift of understanding cognitive neuropsychology and the fundamental architecture of memory itself. Section 3. Building Blocks of Tomorrow. Constructing the Physical and Digital Modern World.
65 million. That is a massive number, right? That represents the staggering tonnage of polyolefins produced today. That includes everyday plastics like polyethylene and polypropylene. Think about the plastic food containers sitting in your kitchen right now, or the protective packaging on your last delivery. That colossal global production is all made possible by Ziegler-Natta catalysts, which were invented in, you guessed it, 1953 by Carl Ziegler and Giulio Natta. They created a chemical route that gave us unprecedented control over the physical architecture of polymers. They literally shaped the material reality of our modern world.
It's really fascinating to contrast the massive physical inventions of the year with the invisible, foundational leaps in computing. On the heavy industry side, you have J.C. Bamford introducing the backhoe loader, completely changing heavy earth moving and construction forever. Meanwhile, the Jet Propulsion Laboratory completed the Corporal I rocket, which was the first American surface-to-surface ballistic missile powered by liquid fuel. But simultaneously on the digital side, the UNIVAC 1103 computer was launched, and brilliant mathematician Alan Turing culminated 15 years of work by using computers to calculate the first 1,104 zeros of the Riemann zeta function, a really fundamental problem in number theory. Humanity was mastering heavy earth-moving steel in the physical world and invisible, complex digital logic in the virtual one.
But hey, 1953 wasn't just heavy industry and deep mathematics. It also radically revolutionized the screens we stare at today. Remember, before this, the world's media was largely experienced in standard boxy aspect ratios and flat black and white. On September 16th, the epic film The Robe was released, debuting the CinemaScope anamorphic widescreen format to audiences for the very first time. And just a few months later, on December 17th, the NTSC color television standard was officially agreed upon in the United States. This fundamentally shifted consumer culture overnight, bringing these wide, vibrant, colorful, dynamic realities directly into the public's view.
Section 4. Uncovering Truths and Hoaxes. Science as a Process of Refinement.
Look, science is a human endeavor, which means it isn't perfect. We rely on it to build our understanding of reality, for sure. But what happens when science gets it wrong? Or worse, what happens when it is intentionally deceived?
Well, the answer is, science eventually corrects itself. On November 20th, authorities at the Natural History Museum in London made an explosive announcement. The skull of Piltdown man, which was discovered back in 1912 and touted for decades as a crucial evolutionary missing link of an early human, was exposed as an elaborate, complete forgery. The scientific community had been completely fooled by a doctored mix of human and orangutan bones for over 40 years. It was a dramatic, honestly somewhat embarrassing revelation, but it ultimately cleaned up the paleontological record and served as a powerful reminder that the scientific method relies on constant refinement and peer review to strip away falsehoods.
And you know, at the exact same time science was exposing visible fakes, it was also finally proving the existence of the completely invisible. In late 1953, physicists Frederick Rains and Clyde Cowan constructed the first neutrino detector using a cadmium water target. Utilizing the Hanford Site nuclear facility as their source, they successfully performed the first free neutrino detection experiments. To put this in perspective, neutrinos are basically ghost-like particles. They are so incredibly tiny and non-interactive that trillions of them are passing through your body right this very second without you ever even noticing. This elusive particle had evaded scientists for years, and this brilliant experiment to finally catch one would ultimately earn a Nobel Prize in physics decades later.
Section 5. The Legacy of 1953, the year everything changed. So, it's time to tie all of these disparate threads, the biology, the medicine, the computing, the materials, and the physics, back together into a single grand journey. From the double helix and the polio vaccine to color TV and the roots of the first transistorized computers, when you wake up, when you take medicine, when you look at a plastic container, when you watch a widescreen movie or type on a digital device, you are literally interacting with the ripple effects of 1953 every single day of your life. It wasn't just a year of isolated experiments. It was a rare, historical convergence of massive intellectual leaps that built the reality we inhabit today. I really want to leave you with this provocative thought as we wrap up this explainer. What year are we living through right now that future generations will look back on as a similar explosion of knowledge? Innovation is happening constantly, often invisibly, right under our noses. Who knows what secrets of life or building blocks of tomorrow are being published today that will define the next 70 years? Keep your eyes open, keep learning, and I really hope this structured journey through 1953 has sparked your curiosity about the science happening around us right now. Thanks so much for learning with me.